All right. So if we are interested in measuring torque, instead of instead of a normal like a normal load or a force, we can use strain gauges as well. So typically, strain gauges are measured onto a circular shaft in order to measure torque. All right. So they're typically put placed on a shaft so that they're at basically at 45 degree angle. All right, relative to the center line axis. All right. Um, and what they'll measure is they're rotated by about 90 degrees, all right, which will mean that the in strain gauge 1 will read equal and opposite to strain gauge 2 for a given applied torque. So we can use that a bridge setup where we have all four of our strain gauges, and remember we had the gauge factor, all right, divided by 4 times the sigma 1 minus sigma epsilon 2 plus epsilon 3 minus epsilon 4 would give us our DEO, DEO over our input voltage. All right, so we know this relationship, right? If these are all equal and opposite, this basically becomes DEO over EI is equal to our gauge factor for our strain gauges times these are all equal, but E2 and E4 are negative, so we end up getting something like this. All right, so if we know, so we can calculate if we know EO, EI, and our gauge factor, we can easily determine our strain. All right. So the maximum stress that's due to our applied torque can be used is defined using the following equation here. All right. So for a given, if we know the torque, we know the radius of our shaft, and we know the polar moment of inertia of our shaft, we can calculate our stress. All right. Now we can calculate tau xy experimentally if we know the strain gauges and the material, the value of the strain gauges and the material properties. Okay, so gamma xy, which is our shear strain, our maximum shear strain, is going to be equal to the difference between uh, our two strains that we're measuring. All right, in our case, E1 is equal to epsilon, E2 is equal to minus epsilon. Okay, so this just becomes gamma xy would just be equal to 2 epsilon. All right, so we could plug in our 2 epsilon into this equation here. All right, and we'd get our value for tau xy. All right, now if we know what tau xy is, we can go rearrange our equation that we had up here to get solve for our torque. All right, so we plug in everything. If we plug in this equation here for tau xy, we multiply that by our j over r term for the polar moment of inertia divided by the radius term. We get this term here, and we can solve for the torque. All right, so that's a basic setup of how you can create a load cell using a torque cell using 4 strain gauges.